Hello everyone, I'm Ettocraft and today I'm going to interview the Imperial College of London's Rocketry team. So could you please introduce yourselves?
Okay, well, I'm Jayden. Ting. I am the airframe and recovery technical lead at Imperial College London Rocketry. I'm a third year aeronautical engineering student.
And I'm Jason. I'm the business and marketing lead, and I also work in the propulsion section.
How did your team start?
So basically, our team was founded in 2018, I believe, by 4 aeronautical engineering students with a common love for rocketry. So they all sort of came together, and they initially had the dream to go to the Spaceport America Cup. And that was what they really built all the rockets to start designing for. I think we had our first launch back then-ish, about 2018, 2019. And then eventually, throughout the year, it just slowly evolved into what it is now today with almost like 140 members or so. So actually, we're growing slowly, but it's a very good progress, I feel. Like, compared to where we started off to now, there's been an exponential progress.
So we mostly began in the aeronautics department of Imperial College London, with the goal of educating our members and the public about rocketry and hopefully creating many enthusiastic engineers in aerospace.
So how is it to study in your university?
Aeronautical engineering, it's a highly technical course, which I think a lot of the students really benefit from, given the fact that there's very considerable deep dives into the fields of aerodynamics, structures, and control systems. Those are our main things we really do a big deep dive into. And the course itself, it's got a 4-year option, which is the main option, which is a master's in engineering. And then there are optional 5 years, wherein one of the 5 years you have got a year in industry or a year abroad placement, which allows you to have your huge amount of credits and stuff.
And yeah, the course itself is a bit hard, but it really does fulfill your passion. Like it's very exciting, and you do learn quite a lot. So I believe I would recommend it. I don't know about you, Jayden.
When you finish your university, what job opportunities do you have? Is it easy to find a job?
It always depends on what you do during university, of course. But from Imperial College London, many prospects are offered to you. So there are many career services and many connections you develop during your courses that help you find jobs. And generally is considered a university where it might be easy to network and have better opportunities after you graduate. But of course, it always depends on the person. And
here at Imperial College London Rocketry, we feel we've given our members a lot of practical experience that helps complement the highly technical side of our course. And by doing that, we've had members, like alumni from Imperial College London Rocketry, doing Ph.Ds at Imperial, working at space consultancies, doing startups of their own, like rocket engine company. We had a member a couple of years back doing that. We've also had a couple members working at ESA and a few with consultancies. So we believe that the skills that you learn from ICLR are incredibly transferable to the wider industry.
What are your team's goals?
Initially, it started with the passion for rockets. So the team was created to build and design and test rockets. But our goal developed into something more solid, which is to educate both our members and the public about rockets and about how you design, how you build them, how you test them, and how you launch them, of course. We've turned it into more of an educational project for everyone, as well as a project where you practice your technical skills.
That's it, and I feel like we've also got, in terms of our wider goals, we've got our separate team of the altitude records team, ART, wherein their sole goal was breaking altitude records. So that's how last year they launched Apex I, that broke the I-class rocket motor record for launches in the UK. And they just keep on striving to go higher and higher. And as with all space teams, at the end of the day, we want to go and hit a space shot eventually. But that's future down the line. Maybe, I don't know, 4 or 5 years down the future. We'll see.
Our goals are essentially to learn everything we can right now and develop knowledge bases so the next people can build better rockets, more ambitious projects, and break more records.
How do you recruit new members to your team?
We have open recruitment for everyone, but our main recruitment events are during October when we start our course. And we have what's called a recruitment event where we members from all of our sub-teams present what each sub-team does to members of to interested people. And essentially, we don't have any filtering. So whoever gets passionate from that, whoever is interested in working in a project, whoever finds that Imperial Rocketry fits for them can easily join us. But again, we have open recruitment throughout the whole year. So if anyone sees our work and is interested, they can always join our team no matter time. So we have members joining even now before, for example, EuRoC.
And also, like, in terms of the members we have, we've got most of the stuff we do is in person. During COVID, it was a bit hard because, of course, everyone was remote. But now here we're trying to get mostly in-person membership because we feel that being in person is the best we can learn. Of course, though, we do have remote meetings quite frequently. Like, I know that our altitude record team, they have frequent remote meetings to go and discuss their separate individual sub-teams. Furthermore, with regards to we don't really give our candidates an exam or something. We sort of just want everyone to feel included. We don't want to go and have someone where they feel gate-kept or locked out purely because of the fact that they didn't meet some arbitrarily set standards.
And we also recruit from every department in Imperial. So we welcome everyone, whoever is interested in rocketry. We mainly consist of aeronautical and the mechanical engineering students, but we welcome everyone.
What can your members learn from joining your team?
I feel that honestly with ICLR, there's a limitless amount of knowledge you can learn, and I feel that a lot of that comes with the fact that for aeronautical engineering students, particularly during our course, there's not a huge focus on rockets in themselves. The course, the main things that we do focus, which is rocket related, is a space propulsion and advanced propulsion module, which handles a bit into rocket propulsion. But there's nothing really about rocket dynamics, rocket structures, rocket aerodynamics, etc., etc., etc. And those are the sort of things that we really go and teach our members, really build on the analyses that are built on for planes that we get throughout our course. Additionally, with ICLR, especially during the third and summer terms, we give our members considerable practical knowledge and understanding in terms of actual machining skills, which is particularly crucial for aeronautical engineers who we do not have the same sort of machining ability as top-notch mech students per se. And we feel we give them this. And within ICLR, I've been able to learn manual milling, I've been able to learn CNC routing, generative design, etc., etc.
Plus, I'm sure a lot of work with composites, which you don't get during the course. You learn how to do layers, how to build composite parts. But yeah, it's mostly practical skills and practical knowledge about rockets that you gain. So there's so many members and there's so much to learn from these members as well. So not only do you learn by building a rocket and building your own part during the year, so you learn the technical side of the rocket, but you also learn how to build it, how to practically construct it, how you can do that yourself. And in ICLR, we focus on everyone learning by themselves and everyone being passionate about something and then learning about it. So in ICLR, there's nothing in particular. There's no guideline in what you will learn, but during your work with the team, you learn so much about your particular sub-team and practically how to build a rocket.
How do you design your rockets?
Basically, the whole design process for a rocket, the way we streamline it, is to take place over the course of one whole year. To start with the rocket from conception during October, the moment we get back from Europe, that's when the conceptual design starts. So basically between middle of October and middle of November or so, then we have a conceptual design as well as inducting the new members who've come to ICLR. And then between mid-November and the end of first term, that's when they start their whole design process. Then the second term, that's where we have a lot of design reviews to verify the quality of the components, as well as just do whole team-wide discussions. And that's where a lot of the parts get finalized and design freezes. And within third term, that's our term when we do prototyping. And then into the summer is where we do most of our manufacturing. And this therefore puts us in a good stage that our rocket should be completed by about September or so.
And that gets us ready to test all our components to be redundant and make sure they work. So yeah, it mainly starts with after EuRoC, when we decide what we want to do for the year, and we follow the path that Jayden mentioned. And throughout the whole year, we review our designs again, and other members of the team get to review and criticize other designs. So by the time we start to build them, we're sure we have peer-reviewed designs that are well built. and simulated, of course.
How's the experimental rocketry community in London?
In London, I wouldn't say it's the strongest community, given the fact that there's a limitation in the amount of free space that you need to actually physically launch your rockets. I do know that UCL has their own rocket team. There are quite a few rocket teams actually at Imperial itself. And then there's also, a few in Kingston University, etc. I don't know exactly where all of them are, but I know that there are a few developing things, but there's no real space to test, which is why here at Imperial College London Rocketry, we are incredibly lucky in the fact that we have our Silver test site, which is literally about an hour's drive outside of London, and we can literally go there and test out our rocket engine, which gives us a real advantage. However, that being said, around the whole country itself, there are numerous sort of experimental rocket launching events and areas. So there's stuff like Race to Space, which is actually happening this week, wherein a lot of university teams have been able to hot fire their bipropellant rocket engines, etc., which is pretty awesome. Also, I know that outside of London, like around Oxford and Cambridge, there's Harwell, which has got a lot of aerospace companies, and there's also Westcott, where a lot of the space companies also congregate. And there's also the satellite applications Catapult, I think. And that's where they can go and test out all their separate rocket stuff. Furthermore, sorry if I'm going on for a bit, Imperial College London Rocketry has worked with also the other UK teams to set up a Discord amongst all of the teams, so that we can therefore share knowledge between all of the SRAD liquid teams and the various other rocketry teams, and sort of just build up the community within this country.
There is quite a big community of amateur rocket and rocketeers, people who launch small model rockets in the UK. Unfortunately, most of it is not located in London because it's quite a difficult airspace to close and quite a difficult place to find a big empty piece of land. But yeah, as Jayden mentioned, there are many teams all across the UK and in London that are interested in rocketry.
Where do you test your rockets?
We are extremely lucky to have our own test site in Silwood, which is, as you mentioned, about 1 hour away from London, from our campus actually. And it's an old Imperial site that is partly for biological research, for an environmental experiment, and we've been allowed access to it to mainly test our engines. So we've tested our hybrid engine Hypnos there, and now our new liquid engine Thanos in the test site. But other than that, we can perform small tests in campus, that, for example, for our electronics, and test launches by ART, for example, they happen during amateur rocket launch events or in Scotland, where they have their own launch site.
What are your experiences at EuRoC?
I've actually been to 2 years of EuRoC thus far, so I can actually give a background of how EuRoC 2021 was, and Jason can cover EuRoC 22. In EuRoC 2021, that was our first year, and it was the second year of the competition, I believe. And we went there taking a solid rocket, which was supposed to be the groundworks for our hybrid rockets. The idea was we'd design a whole rocket that could take all the loads of a hybrid rocket, and then we'd be able to launch it with solid motors and then retrofit a hybrid engine. However, unfortunately, when we got there, we discovered not only the quality of the teams at EuRoC, there was a huge step up compared to what we expected, because we were designing rockets almost like designing a very good amateur rocket. But whereas at EuRoC, you go ahead and see people designing like actual proper rockets, which is honestly mind-blowing there. But I feel that we still did a very good job, and it was crazily stressful. Like, we did some outrageous things that year. For example, we had to go and try and stiffen our body tubes. So I remember this. Late at night, we had our body tubes, and we were trying to stiffen them with fiberglass outside of the bungalows. And we've also had various experiences where we had to put a water bottle that was filled with sand in the nose cone of the rocket to serve as a ballast, in order to ensure our rocket was stable off the launch pad, since we were not allowed to use boosters that year due to the unreliability with simultaneous ignition. And it was amazing. We actually ended up launching off the pad miraculously, though unfortunately we didn't recover. But honestly, it was a great experience. And it was from going to that competition where we got to meet all of these top teams like EPFL, Delft, Bath, etc., that we were able to really go and start kickstarting as sort of the catalyst for further improving our rocketry designs in the recent years.
I think EuRoC 2021 got the whole team excited to do a lot better and to learn a lot more. So for EuRoC 2022, we developed a much more technically impressive rocket, and we even had the second place ranking in the technical report category for the rocket. It was a hybrid rocket engine powered rocket. So we used our hybrid rocket engine Hypnos, which produced 2 kilonewtons and powered by nitrous oxide and paraffin. And so we took that to EuRoC 2022 with a much more developed system. So our whole rocket was developed with being more impressive, being more looked after, and this jump in technical ability was recognized by both the judges and other teams, I think. So we had a much more impressive rocket to show in EuRoC 2022. It was also very stressful though, because we encountered very small bugs and small issues with the rocket, and we were fighting time because we're slightly late to assemble it and get flight approved. So the whole thing was a bit stressful, and everyone was working super extra hard once more. And unfortunately, we had two opportunities to launch, 2 launch windows. And one day we didn't manage to get it ready on time and fueled on the pad and launch it. So we had to scrap that launch. But in the second day, it was ready, fueled on the pad in the last launch window. But unfortunately, we didn't manage to launch it because of some software interference, some software bug that didn't send commands through, which meant that particularly the feed system of the rocket opened, but there was no ignition. So the rocket stayed in the pad. But both EuRoC 2021 and EuRoC 2022 were amazing learning opportunities. And judging from the progress of the team from EuRoC 2021 to EuRoC 2022 and now to EuRoC 2023, I'm incredibly impressed and proud of the team. So they're both incredibly valuable experiences, and we learned a whole lot. But and so we're gonna smash, I think, EuRoC 2023. What do you think, Jayden?
I'm looking forward to it more than anything. I feel like as the years have gone by, since I'm an old man in this team right now. This is my third year here. I have literally seen us growing so much more over the years. So at this stage, 2 years ago, we didn't even have a rocket built. We sort of just got the phenolic tubes. At this point last year, we sort of started prototyping, but it was still a mad rush. But here, this year, we've got our metal components. We've already started our whole composite manufacturing line. And honestly, I think it's going to be amazing.
What were the biggest challenges you faced during EuRoC 2023?
I can highlight some of the challenges we faced in airframe. That's because that was my specialty. Within airframe, one of the challenges we faced was the fact that we wanted to use pre-impregnated carbon fiber for our entire rocket. However, due to financial difficulties, this therefore made it impossible, and therefore we had to revert back to our wet laying up as the previous year. Except what we have done is we have gone and decided to use vacuum bagging with the parts, therefore to improve its quality. Furthermore, we have been able to go and build on all the progress and experience we built from the previous year, which therefore allows us to build the composites faster, as well as also improve the overall quality of the composites themselves. Another challenge we faced was the fact that with our parachute, we wanted to initially reef our parachute. However, there was a lack of manpower, and a lot of the critical members for designing the parachute were ill for considerable amounts of time. This therefore meant that we couldn't design a complete reefing system. So therefore, we've developed part of reefing, and we'd like to go and carry on said research next year. But we'd have to go with our clamp band and drogue main this year, unfortunately. But otherwise, it was just part of the learning experience. And, a big part of being in a competitive rocket team is you have to make these hard decisions.
And I can also tell you a little bit about our propulsion team. So this year we aim to develop a liquid bipropellant rocket engine, which is incredibly hard. And we faced a lot of challenges during the developmental phase and during the testing phase, because it's been hard to get reliable components ready. So, for example, we've had issues with some components leaking, for example, some tanks leaking during tests, and us having to scrap them and design new tanks or order new tanks. We've had issues with ignition. We've had to solve how to ignite a rocket engine, because there were some reliability issues in the start. We weren't able to get it to ignite. And there are also many design considerations that you learn while you're testing. So it's been a very challenging year developing such a difficult engine. But so far, as you might have seen, we've had a hot fire for a whole flight duration. So a full flight duration burn, which was extremely impressive. And we're on our way to finalizing the engine and getting it ready for full wet dress rehearsals, where we have integrated tests. And yeah, we'll be ready for EuRoC then.
Oh, yeah, but all of these like challenges we overcome, it's almost like debugging for code. So if we find the issues now, it therefore means that we won't have these issues at EuRoC, which therefore increases the safety of our launch, as well as the reliability and probability of success at EuRoC. So we take it in our stride.
Would you like to join another competition apart from EuRoC?
So with this, the main competition which is most attractive is the SA Cup, but unfortunately, the SA Cup is timed to be around March, April, and the problem with, I believe March, April, right? And the problem with that is it's scheduled basically during the third year of their GDP deadlines and stuff, which therefore makes it very stressful for them, because they can't really fly off to the US with a full rocket ready during that time, since they've got their major deadlines and their course is literally the most important thing. Additionally, fourth year students have got their final year project at the same time. So only first and second years would go, but that sort of means that you would lose out on a lot of the experience from the older years. However, we'd love to go, but just at this point in time, wherein there are such exorbitant costs to go and ship all the parts to the US and to launch the rocket, we feel that going to EuRoC, which is timed very well for us, and also allows us to interact with teams with, six-figure budgets that greatly overcome ours. It allows us to learn more because they're building like state-of-the-art rockets and with like really complex technical achievements in there. And we feel that going to EuRoC allows us to assimilate more information for now. But in the future, SA Cup, we feel will be a great way to go and launch something like a COTS space shot or something. But just not right now, maybe 3-4 years in the future. But who knows what happens.
SA Cup is an amazing competition, and we would love to join it. But yeah, there are very many issues with logistics for our team members, and quite frankly, the cost of it for bringing many members would be quite insane, and it would have to be out of pocket for many members. So that definitely prohibits us. But it's always we're always looking for the next challenge. So if that is the next challenge that we have to do, for example, for a space shot COTS, then we go to SA Cup. But we see how our team progress goes and where our next goals lie. So yeah.
Okay, well, what softwares do you use both for simulating and for designing?
So for designing, we're incredibly lucky to be sponsored by Autodesk, which provide Fusion360, and our whole team is able to use Fusion360 to design and CAD parts. And it's incredible because we have the ability to work on a cloud sharing, cloud-based CAD software. So the whole team can work simultaneously on many designs on the cloud, and we can all assemble them together in Fusion360 in our team cloud. So we mainly use that for CADing. Now, for simulating the rocket parts, we also use Fusion360 for structural simulations, for example. But we can also use other software such as Abacus to verify results.
Also on top of using stuff like Abacus, which really allows us to get really good, high quality, high fidelity simulations. In fact, we actually devoted an entire subteam to the study of simulations. For trajectory analyses systems, they've used Rocket and RocketPi, as well as StarCCM Plus to analyze the aerodynamic flows around the rocket. And I know that we're also using Simulink and MATLAB to go ahead and code up a lot of the modeling for, I think, some of the propulsion elements. And I know that the electronics assembly, they go and build up some of their own softwares to run PickleRick, etc.
Software used for electronic boards, it's called KI CAD. That's what our team uses to design its own custom built electronics boards, because our own electronics team designs and builds their own boards. So we also use a software to do that.
What recovery system do you use?
Basically, the recovery system we use in our rocket, it's a clamp pad system. This builds on from last year. Last year we made a simple spring plate that separated the coupler section. And now this year we're using a clamp band. We're using a clamp band due to its positive retention during ascent. And this therefore allows it to have a clean separation apogee. And this overall creates a much more reliable system. Furthermore, we feel that with the clamp band, we'll machine them all using machine them using CNC routers, and this therefore will create a very high levels of tolerance, which will therefore overall create a very stiff joint in that section. Additionally, with a clamp band, it also moves away from black powder, which therefore makes it a reliable system since we're allowed to test it very frequently. The laws for obtaining and testing with black powder in this country are very strict, so that's been a big move away from black powder-based recovery. And therefore, after that, we then use a drogue and main deployment. We use the combination, of course, to go and slow down so we don't drift too far. Our main chute, unfortunately, it's not brightly colored. It's a white chute, and this is done because we're using the same parachute we used on Sporadic Impulse last year, which was bought during financial difficulties for our team. Furthermore, we also use a 3-ring release system to go and initiate drogue and main separation. This is more reliable than something like a chute release. And these are all actuated using nichrome wires, which our team has considerable experience now using.
What is your rocket's payload?
This year we wanted to perform more experimental payloads because we felt that we didn't have a good enough payload. Not good enough payload, sorry. A very experimental payload for last year. So we wanted to do something more impressive. And this year we've decided to go with a soft landing payload that uses an deployed airbag to slow its descent down. And we are going to be featuring many experiments inside, which not all of them are fully confirmed yet, but they're very impressive.
Yeah, this also builds on from, basically, we've been developing payloads for a while, so builds on from our awards we've won during the CANSAT competitions in 21 and 22, wherein we entered Vlad, which is a CANSAT that was launched with a spike on it, to go and test out soil samples, and we also launched Icarus, which had foldable solar panels, which we tried to launch at EuRoC last year. So we'll see as it goes. We'll see basically trying to develop more and more technology. So the idea is by having stuff like soft landing systems on our payload, etc., we'll be able to go and test out more payloads and provide us with a unique offering for other companies that want to put experiments on our rocket.
And because of our CubeSat design, it's very easy to slot on more experiments always. So we're always looking for more people to get involved with our payload and provide their own experiment.
Do you know Kerbal Space Program?
I think both of us have played quite a lot of it. I think I have too many hours to be healthy on it. And yeah, it's a game I love. KSP.
Unfortunately not, actually,
no?
Which I know is terribly shameful for an aerospace engineer.
Quite.
My video game was doing exam papers.
Do you have any announcements you want to announce?
Biggest announcement we have is that we started manufacturing, really, which is pretty incredible. We've been plugging away for the past couple of weeks, actually. So we've got our composite setups ready, and we're making them daily. It's honestly kind of scary how efficient we are with that. And also we're starting to order all of our metal components. So we had our stringers, our bulkheads recently come in, and now all that's left to do is post-machine them. And we've also had, we're also going to start ordering in our final components. Also our generatively designed truss structure will be coming in a couple days. So that's also super exciting.
So yeah, we have many updates from all across the team. A lot of progress has been made, and now that manufacturing has started and actually ordering components has started, we don't have a particular big announcement ready, like the rocket being fully ready, but it's just small, incredible updates. I guess our most recent update would be the full flight duration burn of our bipropellant engine that was performed a few weeks ago. And also a big announcement is our EuRoC video and our EuRoC mission patch, which should be coming along the coming days.
Do you have any advice for young Rocketeers?
For me, my greatest advice is to go ahead and really just go for it, because I feel that's something that stops a lot of young people nowadays is when they come up with a dream that they have, they go ahead and think about it for too long. And I feel like if you just really have a passion for something, regardless of how infeasible it sounds, regardless of the perhaps daunting idea of low pay in the future, I feel like if you just go for it and if you just stick to your dreams regardless, you never know where it's going to take you. Like, I know there are members in ICL right now. In fact, our next electronics lead, he was dragged to his first meeting. And then he came in there and he enjoyed it so much. And that has super inspired him to really take charge. And now, honestly, you can't get him to shut up about rocketry.
Yeah, he's just too hardworking, too passionate about it. It's quite annoying, you know, because he's always there. You can't get rid of him. But yeah, for whoever is really even slightly interested about rockets, from our team, we really wish that you just do it. Like, you just commit to it, because it really is an amazing experience, and you learn so much from even the smallest rocket you build, even from the tiniest progress you made. And really is worth it. Any sacrifice you make, like time, money, all of that, it's all worth it, in my opinion, because it's incredibly exciting. And at the end of the day, it's a very difficult subject, and learning about it gives you many great skills. So even if it's for amateur purposes or you want to do it professionally in the future, you should always start with building something and pursuing this passion. And you always find ways to overcome time issues, for example, and money issues. So yeah, just go for it.
What are your favorite space movies and YouTubers?
Definitely BPS Space, and then definitely Imperial College London Rocketry.
Definitely.
And in terms of favorite space movies, my personal favorite's Ad Astra. Brad Pitt. Great film.
Good choice. Yeah, beautiful movie. I'm going to change my answer a little bit, so I'm more original. I'm going to go with Scott Manley, incredibly impressive YouTuber, and has taught us so much. And I've personally grew my passion watching him. And Tim Dot, the Everyday Astronaut, credits to him as well. Both of them do amazing work. And I think I'm going to go with a more mainstream choice for a space movie. I'm going to go with Interstellar, because yeah, it really is quite an amazing movie, standalone movie. But it's also incredibly space exciting, you know. What about you, Ito? What's your favorite YouTuber in the movie?
Well, YouTubers are definitely like PS Space, good YouTuber. Also, Everyday Astronaut, very good too. Scott Manley is also a good YouTuber, space YouTuber for space movies. I don't know. I mean, Interstellar is also a good movie. I guess that would probably be my favorite space movie.
Good choice.
Do you have any questions for me?
Are you going to be a EuRoC in 2023?
My team has. I do sort of have a team, though I don't even know how many members it has. But it's definitely less than 10 members. And there is no file for a possible rocket, no design. So the probability that we would be able to build a rocket for EuRoC and go there in the little time left is very small.
Would you like to attend as a spectator and come see all the teams and what they've built?
Yeah, I believe I will go there as a spectator.
Fantastic.
As I did last year. This year there will be some new teams, for example, Astra Bremen.
Well, we hope to meet you there then. Should come by our beautifully designed stand.
Yeah, also, Esso, what are you planning on doing for university?
I mean, I haven't really decided which university to do. Probably one of the best universities I've seen is the one at Delft.
Great school.
Good university and good rocketry team. Also because since you only have 5 years at university, if you start a team, probably won't be very big by the time you end. I don't know, it depends on how you make the team.
It's okay, you can do a Ph.D. afterwards. There's one member in ICLR. He was a normal member for 3 years. He became airframe technical lead, then airframe executive lead. And now he's demoted himself to just a member again for the duration of his Ph.D. So we're going to have a member who's going to stay in there for 6 years, probably.
I guess I could use a PhD as an excuse to stay longer.
Yeah, it's a great excuse to build rockets, because once you graduate, you don't get that many opportunities, unfortunately, to get that much involved in a rocket. So I think I definitely might follow the same strategy and stay a little bit more, you know, especially if we go for like a space shot or something big like that. How did you get involved in rocketry, Eta? What was the main thing that you find attracted you to rocketry?
Well, I started with solid rocket engines. I actually don't remember why I started. I need probably, if I have to work on some part of a rocket, it would probably be the propulsion. I don't remember why I started making rocket engines, but I did start making them. Then I spent a couple of years trying to make them better, and sort of failed to make them better since they still they still fly about 50% of the time, which isn't a high enough success rate for you to build an SRAD engine at EuRoC, probably. Also because you don't want to have a 20% chance of the rocket exploding. Ideally, you would have less than 1%.
Yeah, the 20 is a little bit high. But you can always improve that, I think.
And also, it's incredible, someone your age building rockets already. When I was your age, I was still a socially awkward teenager, not really doing much of anything.
Building small rockets is easy. Building rockets that go at EuRoC is hard. Well, I guess that if you have a team of 10,000 people, then each person doesn't have to do much work to go to EuRoC.
We are fortunate to have one of the biggest teams, but of course, each member decides how much they get involved. So it's difficult to get everyone's whole time into ICLR. And I think that's what usually happens with many teams. There's many members that are interested, but and many members that get involved, but the distribution of parts becomes more difficult. How many rockets have you flown personally?
Well, I basically made only engines. It's probably in the hundreds.
Hundreds. Wow.
Wow.
I think we've flown fewer rockets.
Yeah. There was a time where I made like one rocket a day, and launched a couple rockets once a week, and that period was over a year. So, wouldn't be surprised if like I flew 200 engines.
I salute you.
Yeah.
At least tested 200 engines. Maybe just 50 flew.
That's still an incredibly impressive statistic.
Well, they were just engines. There weren't any fins, nose cones, electronics. So
that's the easy stuff.
Yeah. The whole airframe is super easy.
Yeah.
Well, if you want any advice or any help with the propulsion section, all of our propulsion members are always very welcome to share around any knowledge we've gained and any experience we've gained. So by all means, if you're stuck at anything, feel free to contact us. We'd be more than welcome to help.
Yeah, lately I've been trying to make a liquid engine, and I haven't had much success.
It's quite a big, yeah.
I mean, it depends what you define success as. The engine didn't blow up, but its thrust was less than like 100 newtons.
Well, less than 100 newtons of thrust, if your rocket's small enough, you're still good. In fact, the fact that it ignited is the most incredible part.
Yeah.
Again, it depends what your definition of a liquid engine is. If you pour some ethanol on the floor and light it on fire, is that an engine? And it would produce thrust.
What do you build your engines to do? What's the goal of them? Is it just to test them?
The goal is to get like some 100 grams. I mean, if I could make, I wish I could make it 1 kilogram of thrust or more, but I don't think I will get there in the near future. I mean, I would like to have an engine with a TWR more than one. So if the engine weighs 1 kilogram, I would like it to make at least 1 kilogram of thrust, which I have yet to achieve, even though my engines weigh like 10 grams.
All about being patient. Everything works out in the end. That's one thing I have learned from this course. That you might go through so much heartache, so much stress, so much trouble. But by the end of it, everything works out.
If you work hard enough and you put the time into it, it will work out. Like we can guarantee that. And you always learn more as you go. So even failures, they're a great point of learning, you know. If the engine fails to ignite, that's a great opportunity to learn about ignition methods, you know. If it hopefully not blows up, but if it does, you learn how to design a stronger one. Yeah, you learn how to design a more powerful one. It's this whole work. It's a process. Yeah.
Yeah, I mean, if you don't fail, then you can't really go forward.
And as a great man I know said, he said, everything happens for good.
I guess that could be true.
It's our team motto, I think.
Probably people normally aren't happy when their engines blow up.
No,
it's that initial disappointment. You're disappointed at first, but then when you look back on it in a while, you'll be like, you know what? It was right that it exploded then, because by exploding then it taught you all the lessons that took you to where you are now.
And you also have to think that if it doesn't explode on a test stand where hopefully it's safe, then it might explode on your rocket. And I don't know about you, but I usually prefer it to blow up on a test stand and not blow up the whole rocket, which is our main goal, not to blow up the rocket.
So when you blow up the rockets, you don't damage your test stand, and it's more like a firework. Well, except if it blows up directly on the launch pad.
Well, you could say it's a big firework, but I think blowing up a whole rocket comes to a much greater extent than blowing up a well-designed test stand that's meant to withstand a blow up, an explosion. So.
Yeah, test stands are meant to withstand explosions. Rockets normally aren't meant to explode, because even if the rocket survives the explosion, it would probably crash. So
that's why you hire a good recovery team, so your rockets don't crash, and you make sure all your recovery avionics works well.
Are you that confident, Jayden, that our rocket will recover even if it blows up?
I'm 90% sure. We'll get something back.
That is true. You always do get something back.
I remember the last time we went to EuRoC, the Polish team's rockets. They had a full bag of carbon fiber scraps from where the rocket crashed. That rocket didn't explode. It only crashed.
At least, you get all the cool marketing photos of it going up. That's the important part, right?
Yeah, that's the important part. Except if you wanted to reuse the rocket, then maybe suboptimal.
Okay. Build a new rocket. Build a better rocket.
The problems of a limited budget.
Launching them is one thing. Recovering them is a whole other part. So I think every team is happy, even if it doesn't recover. We are not hoping for that. Just to be very clear. we would love to reuse our rocket, and but it's always a success. We always have to remember that.
Getting there's the success.
Yeah. When
you get there, you're already 80% there.
What fuel do you want to use for your rocket engine?
Currently, we're using methanol and nitrous oxide, and nitrogen as our pressurant. So we're running a pressure-fed system. Hopefully, in the future, when we might want to do active cooling, we might want to do higher performance rocket engines, and maybe even like gas turbines or gas generator turbines. We might want to use liquid oxygen. Of course, it always gives you better performance. And in terms of fuel, perhaps some higher, better performing carbohydrate, or something more impressive like methane. But I think the next progression might be liquid oxygen.
Liquid oxygen is normally quite cold, so cryogenic propellant.
Whole new headache you have to worry about. Cryogenics
it's another opportunity.
It is an opportunity to learn, but it remains a headache. Because they're quite dangerous. You have to be very careful during your whole procedures. Of course, it's more difficult to source and have on site and store it. It does offer much greater performance, and if you want to make the next step, it might be something necessary. But it's an issue designing the whole engine, the whole feed system, the whole tanks, all of that to be cryogenic proof. For example, we had a lot of issues with valves, for example, because when we did cold flows and vented nitrous oxide, in the past we had solenoid valves, and it got so cold that they froze open, for example. So if you have liquid oxygen, you have that problem, but you have that during your regular operations. So you have to account for that. Very difficult fuel. Oxidizer, sorry. What is your engine powered by?
Well, currently it's ethanol and air. I'm currently thinking of making it run on hydrogen and oxygen, Probably electrolysis of water, in my case, is the easiest source of oxygen. If I get hydrogen, why not use it? I wonder how dumb of an idea it would be to make my engine run on hydrogen and oxygen, since it would probably blow up.
It's quite an explosive mixture, I would say. And it might be a little bit difficult to light it. Hydrogen and oxygen, although it's very combustible, it's difficult to ignite. So you might have issues with spark plugs, and that might lead to another issue of blowing up, because if you fill your combustion chamber with too much.
If it's full of hydrogen and oxygen, then the rocket will probably blow up when I try to ignite it.
Yeah.
Usually to ignite rockets, I set the nozzle on fire, which isn't a very professional way of doing stuff, but it works. Just cover the nozzle on ethanol, light it on fire, and normally ignites. To remove the hazard of explosions, it's partially remove the hazard of explosions, I could do that. I start the engine going hydrogen-rich, fuel-rich, so that it's not as explosive. And once it ignites, I can increase the flow of oxygen. So that would just make it more complicated.
That's a good idea. Yeah, but you have to have a very good control of your fuel and oxidizer flow. So you'd have to have a pretty complicated feed system, but it's definitely the safest way possible. You could also use a third fuel, so you could use ethanol to start the engine out, if that's a concern.
Yeah, I could
then transition it to hydrogen.
I mean, I could make it run on two fuels and oxidizers to make it start with the ethanol and air, and then start it with oxygen and hydrogen, and then remove the ethanol and air. That would just make it more complicated. I guess I'll just put some valves which I can turn. One thing that I should probably worry about is the hydrogen tank detonating, because if air gets in there, it won't be too nice.
You should always calculate the possibility of backflow. You always want to have your feed system at a higher pressure than your combustion chamber. So I recommend looking into that very carefully.
I believe there are these things called bubblers. I don't know how they're called. But there's a tube that goes into water and it makes bubbles. So in case if the hydrogen starts igniting, the water will stop the flame and the entire tank won't explode. Because I would probably need lots of hydrogen, like a couple of liters. I'm not sure if I want to see what happens if all that hydrogen blows up.
Yeah, especially if it's at high enough pressure, you really wouldn't want that.
Because it would also be pressurized, probably. Because I don't have very big water bottles currently.
Probably want to upgrade your tanks instead of water bottles.
Yeah.
Use some fire extinguishers. Those probably won't ever fly since they're quite heavy.
Once you test it and it works, the engine itself, you can always upgrade your tanks to flight-worthy tanks, much lighter tanks that can handle it.
And for now, water bottles would probably be enough, since they can probably, I believe they can handle over 6 atmospheres of pressure, 6 bar. So that should probably store some hydrogen. I mean, it's a 2-liter bottle at 6 atmospheres, that's like 12 liters of hydrogen. One problem that I might have is that the hydrogen, like to burn hydrogen and oxygen, I need more liters of hydrogen than I need of oxygen, since the hydrogen is lighter. Well, I guess that's why I can turn the valves, so I can regulate the mixture and try to achieve stoichiometric.
Yeah, you might have to burn it at a worse OF ratio, but which might be a good thing actually, because you get like lower temperatures.
Yeah, maybe I will run it like, as you know, oxygen rich. Or if I see that it's, or I could run it on hydrogen and air, and that would be cooler instead of hydrogen and oxygen.
Why do you want to make the step to hydrogen?
Because I would like to run it with a more powerful oxidizer than air, since there is only 20% oxygen. And I think that using oxygen is the easiest oxidizer I can get. I don't have any nitrous oxide, so just doing electrolysis would probably be easier. I'll grab like 5 computer power supplies, make lots of electrolytic cells, electrolysis cells. I don't know how to pronounce it. Do lots of electrolysis and get some hydrogen and oxygen. Electrolysis is most efficient at about 1.4 volts. So maybe I shouldn't directly use 12 volts. Electronics isn't so easy.
Yeah. All of the separate elements, none of them easy.
Because then if I lower the voltage, then there's the problem of not enough current flowing because of the resistance of the water. So I would need bigger cells if I want them to be more efficient and produce the same amount of hydrogen and oxygen.
It's a very cool experiment if you try and optimize it, you know?
Yeah, I mean, it should be useful to have some hydrogen and oxygen. Maybe I could make like a torch to melt stuff.
Or balloons, if you want.
I could make explosive balloons.
I was thinking more of party balloons, but sure.
I guess I could fill balloons with just hydrogen and make them float up.
Yeah.
I wonder if a mixture of hydrogen and oxygen would be able to detonate. Like, does hydrogen and oxygen burn faster than the speed of sound?
I believe it's a pretty explosive mixture. It might detonate.
Well, apparently a mixture of oxygen and hydrogen can burn when the hydrogen content is between 4 and 95% by volume. That's quite a big range. And it's also scary because that means that 5% of air in my tank is enough to make the tank detonate, or at least burn. You know, it's seriously starting to wonder how dumb of an idea it would be to connect like 12 liters of hydrogen to an engine. I mean, if we have 5%, since air isn't pure oxygen, I would need more than 5% of air. Probably like 10%. And even at 10%, the flame would be relatively slow. It wouldn't be a detonation. The worst thing that can happen is that the bottle blows up, I guess, and maybe damages something.
Make sure you're a great distance away from it. And don't use manual valves, ideally.
Yeah. Use like a servo or something. That way you can better control your OF ratios.
Yeah, the valves would be a problem because I do have some high voltage transformers, ZVS, and the spark plugs. So I could light it from like 10 meters of distance with a button, but the valves would be harder to do. Since I only have these manual valves that are made for water and not hydrogen.
Safety first in all of these designs, like you might just go for it, but still. Exercise, safety, and precautions.
Hydrogen could leak from the valves. But again, most things that can happen is it blows up.
Yeah, it's generally the worst thing.
I would need to find a good way of storing it. Also because I'm not very good at making airtight things. I believe that you can generate pressure with electrolysis, but I don't believe my electrolysis cell would be able to handle like 6 atmospheres without air, hydrogen, or oxygen leaking.
It might be easier to start with like a hybrid engine because hybrids are generally a good stepping point between solid motors before liquid. You don't want to bite off more than you can chew and see what happens.
Yeah, the only thing about hybrid is that I would still need oxygen. And if I produce oxygen, I might as well use the hydrogen. If I am able to make...
you could use a different oxidizer.
Well, yeah. You could...
Like hydrogen peroxide, I believe?
No, don't use hydrogen peroxide.
I did have some like 30% hydrogen peroxide.
30%? Oh, okay. Do not use that. Yeah.
It was 30%. Now it's probably like 1%. Anyways, I still don't... if you mix ethanol with it, it won't burn or explode.
You might need pretty high pressures for it to burn.
Maybe.
But I would not recommend it. It's quite dangerous.
Ideally, I would have some catalyst, and the hydrogen peroxide would flow through the catalyst. The air would be ejected somewhere, and the hydrogen would go to the engine. But that would just complicate stuff. Electrolysis is easier.
Yeah, but I think Jayden had a good idea that you could use solid fuel, and just extract the oxygen from the electrolysis. It's easier to handle. And once you build the oxygen feed system from the electrolysis.
Okay, maybe that's smarter because I don't risk blowing up the oxygen tank as much. Since normally there isn't much fuel in the air.
Well, if it was oxygen, I would not recommend using plastic bottles because that might react with oxygen if you have a high enough temperature flame that backflows. So
no, the combustion chamber is not made of bottles.
Not the chamber itself, but still, and the tank, because if you have a high enough pressure and it backflows. Being a plastic in an oxygen-rich environment is not.
It's going to burn.
Yeah, maybe going for a different tank for the oxygen as well.
I mean, I do have these metal drinking bottles. I don't know how they're called. Metal bottles. Or I could use a glass bottle.
Don't worry about glasses. In case it explodes, lots of very dangerous glass fragments.
Yeah.
I could grab a glass bottle and put it inside of a tube. But then stuff gets more complicated.
The issue you might have with glass is the interaction between the glass and whatever your plug is. So
yes.
Your end bit. If it's metal, it's much easier to...
Well, I guess it depends on what my fuel tank and what my pressure will be. Because like I could use like something put upside down in water and filled with oxygen as a tank because it's relatively airtight. So that, if the pressure goes up, then it will just bubble up. The things that I call the bubblers are apparently flashback arresters, they're called. I probably should use some of these flashback arresters if I want to use hydrogen.
Just saying, the fuel for a hybrid could just be paraffin wax. You can literally use candle wax, which I'm sure it's very easy to find. Like, you know, you don't want to try to shoot for the moon, shoot for Mars before you've gone to the moon.
Yeah, I've used wax for some stuff in the past. Remember the time that I tried to make high voltage capacitors with wax? The problem is, wax isn't that easy to cast.
You'll be surprised. I think last year we cast it on an electric stove.
Well, we melted it on an electric stove, but usually wax is... We did have some problems with casting it.
It is easy to melt, but the container itself isn't that easy. I guess I could just blow oxygen on a candle. I don't need a tube of wax. I guess I could grab a candle and make a hole in the center of the candle with a drill. And that would be a cylinder.
Yeah. And also use the wick as your igniter.
The igniter also isn't that simple with... Well, I guess I could just use some rocket candy, shove it in there.
Or black powder.
I actually don't have much black powder. Since they don't sell black powder here for some reason.
I wonder why.
I also wonder why. It's not like it's explosive.
Well, rocket candy might be a good starting agent. Have a small rocket candy fuse.
Yeah, I remember that Skyward used rocket candy as the igniter. At least in their test. In the final rocket, I don't know if they use rocket candy.
There's some teams that use that as both an oxidizer and an igniter.
I've tried using wax as a fuel in the past, and it's not that easy to ignite. It needs lots of temperature.
So you use a small rocket motor, like an A-class motor, to ignite it.
Yeah, probably a spark plug wouldn't be enough. No, this is one of the reasons rocket candy exists.
Yeah, unfortunately, spark plugs don't really work with hybrid engines because you'd have to make a contact with it. But there is a cool method of spark ignition using ABS, where, if I remember correctly, there was a method where ABS itself sparked, and it sparked at high enough temperature to ignite, I think. But yeah, I don't quite remember the method, to be honest. But I know that there was one. So you could use ABS as a fuel as well, if you have a 3D printer.
You can use.
Well,
you can also cast wax into ABS pucks.
Well, if you have a high enough voltage, then you could just make the wax arc from one side to the other. Since basically everything becomes conductive at a high enough voltage. Though you would need very high voltage and current to generate the amount of heat required. Well, again, electronics is not that easy.
That's why we're not in the electronics.
Exactly, they're hard at work right now.
Maybe I will just go for now with an oxygen ethanol rocket. Probably one of...
You should always perfect something before you move on to the next. You know, it's always a good advice, and you should always step up, of course. Like progress steadily. Like build something, test it, make sure it works well, and then move on to the other thing.
Maybe I could use the hydrogen for a whoosh rocket. Two things that I have never been able to do but have tried are a potato cannon and a whoosh rocket. I am not able to make them start. Which is sort of weird. They're supposed to be very easy to do.
maybe you should like get a bunch of friends, get your friends' input on it. Teamwork makes the dream work.
Well, I guess I could just shove hydrogen and oxygen in a whoosh rocket, and there's like no way it won't move.
But yeah, if you need any advice from us, from any members of our team, feel free to message us. We'd be more than happy to help. But thanks so much for the interview, Ito. It's been a pleasure talking to you.
Okay, well,
Yeah.
Thank you. You've answered my questions. You have come here.
We hope they've been
Yeah.
useful answers. Yeah.
They probably have.
And like, good luck with your stuff. Hopefully you can get your bioprop /engine /working.
Let's hope so. How hard could it possibly be? It's not like it's rocket science. Thank you for being here.
Yes.
Thank you for featuring us. We wish you the best of luck with your rocketry, and we hope to see you in Europe.
Yeah, we will probably see each other. I wish your rocket will work.
Thank you.
It will. It will.
You will.
Liquid rockets are hard.
They are.
Quite.
Lots of the time they don't work. Thank you.
Yeah.
And goodbye.
Thank you. Goodbye.
Have a great day. Pleasure.
Bye.